Hello and welcome to our assembly programming tutorial. In this tutorial, we will explain the basics of the assembly programming language. Although assembly is not the language for programming commonly used today, however, learning assembly is a must for any professional developer, not for the purpose of building programs, but for the purpose of understanding how the pieces of program works inside the central processing unit. Building assembly program require knowing some of the target processor instruction set, different registers, and memory area that will be used during execution. Let us first start by exploring the 8086 registers. So here are the 8086 registers. We have the AX, BX, CX, DX, and these registers, all of them are 60-bit registers, and the AX, BX, CX, DX are divided into two registers. Each one is 8-bit, an H and an L. Let's first start by the AX register. It's the accumulator register, and then we have the BX register. It's the base register. CX count register, DX the data register, and then we have CS, which is only one part, it's not divided. It is the code segment, and IP is the instruction pointer. SS is the stack segment. SP is the stack pointer. BP is the base pointer, and we have SI is the source index. DI is the destination index, and DS is the data segment, and DS is the extra segment. So here are the registers in the 8086 processor. Now let's explore some of the instructions, the basic instructions that we are going to use later on while building our first assembly program. To do this, we're going to work on emulator 8086. You can download it from the link below in the description. Let's start. We create a new file and a simple and tiny executable file format. Okay, let's first start by the move instruction set. By the data movement instruction set. We have first the move instruction. This move instruction is used to move the contents to a register or from a register to another. For example, we have move AX and 3, and we have move BX and 5, and then move AX BX. Let's emulate this to understand this instruction. For example, the move AX and 3 will move 3 in the register AX. So when we execute this instruction, so here that as 3 was added to the AX register, and the same for the BX, and the move AX BX supposed to move the contents of BX into AX. So here that the 5 was moved to AX. So here's simply the usage of the move instruction. Now let's discuss some of the calculation instruction. First, we have the add instruction. For example, we can add the contents of two registers to each other, or we can just add a value to the content of a register. For example, if we said add AX and 30 hexa and add AX and BX. Let's emulate this. We are having an error. I'm sorry, this is not a point. Okay, now it's fine. We'll do the same, move AX and 3, then move BX and 5, then add AX and 30. So now the value of the contents in the AX would be 33, and then if we said add AX and BX, so 5 will be added to 33, so it will be 38. So here the add instruction, Now let's move to another instruction, for example the subtract instruction. It is the same as the add instruction, the same way of usage. We can just say sub ax and 1, and then we can say sub bx. A sub is for subtract. So here we move ax and 3, move bx and 5, then we'll subtract from ax 1, so the value will be 2, and we'll subtract the contents of ax from bx, 5 minus 2 will be 3. So here the subtract instruction. And then we have the multiply instruction. This multiply instruction is used to multiply two values. For example, if we said multiply bx, now this will multiply the contents of ax with bx, and the answer will be stored in dx and ax. Let's emulate and see this. We'll first move ax and 3, move bx and 5, and this multiply will multiply the contents of bx with the contents of ax. 5 multiplies 3, and it will be stored in ax. So here's it, f, which is 15 in hexa. Now let's see the divide instruction. For example, if we said divide bx, and this will divide the contents of ax by bx, and the quotient will be stored in ax and the remainder will be stored in dx. Let's see this. First move ax and move bx and then divide. Now we have the quotient in ax, which is 0, and the remainder in dx, which is 3. Now we finished the basic calculation instructions. Let's now move on to some program control instruction. We have first the jump instruction. This jump instruction is used to transfer the program control to a specific memory location. For example, if we said jump and then start, and then we added here a tag start, and in this tag we said divide bx. Then when the program comes to this instruction jump, the program control will transfer to the memory location or the memory address of the start tag. Let's see this. We move ax, move bx, and then jump start. It will directly move to start and divide bx, and then return. So for example here, if we added move cx and 3 and emulate, the program will skip this move cx and 3. When he comes to this instruction, he will jump to start and skip this. We have another instruction, which is the loop instruction, which is used to repeat a group of instruction until the condition satisfies. This condition may be, for example, cx is equal to 0. Then we have the call instruction. The call instruction is used in the same way as the jump instruction, but they have a slight difference between them. The jump instruction doesn't have a return instruction. You just jump to the memory location and never come back. While the call instruction, you will return back to the memory from which it was called. Let's start this and see what's going to happen. For example, here when we change from jump to call, when it was jump, it just skipped this move cx and 3 and never come back. But here it will call start. I'm sorry, I forgot to add something. We need just to add here return. Okay, it's added. We'll come here, call start, move dx and return. It will return back to the move cx and 3. So it won't skip, it will just execute the instruction in start, then return back. So now I think we finished the basic instructions. Let's now see some interrupts. Interrupts are subroutines written to handle input-output devices. These subroutines usually are built in the BIOS. It's a signal to the processor emitted by hardware or software indicating an event that needs immediate attention. For example, we press on a key in the keyboard. So the interrupt alerts the processor to a high priority condition requiring the interruption of the current code the processor is executing. So the processor responds by suspending its current activities, saving its state, and executing a function called the interrupt handler to deal with the event. The interruption is temporary, and after the interrupt handler finishes, the processor resumes normal activities and returns back to what it was doing. We have two types of interrupts: hardware interrupts and software interrupts. Let's see some of the interrupts which we are going to use in the program we will build. For example, we have the interrupt 16. This interrupt is responsible for obtaining basic keyboard functionality. For example, we can press on a key and store the value of the ASCII of this key in the register. For example, if we come here, we don't need this, and we move AH and 0, and then interrupt 16 H. Here we move AH and 0 so that the program understands that I want to store the value of the keyboard input. So he is expecting an input from the keyboard and he will store it in the AL register. Let's see this. We'll emulate and move interrupt 16. So here the program is waiting for an input. For example, if I press 1, then here you found that the value of AL will be changed into 31, which is the hexa of 1, or sorry, the ASCII of 1. We have also another interruption, which is interrupt 21H. This is responsible for the DOS function dispatcher. We can use it to display output on the screen. For example, if we have here, for example, we will add here a message and EB and hello world, and you need to add a $sign in the end of the string. And then here, to get an output on the screen, you will need to move in AH9 and move in DX the value of the output, which is message, and instead of this, interrupt 21H. Let's emulate and see this. So okay, single step. I'm sorry, we need just to do something here. We need to add start tag here, and here we'll jump start. Okay, let's try this. So here it will jump start, move AX and 3, BX and 5, move AH and 9, and it will add the DX, the value of the message, then interrupt 21. So here that hello world will be viewed on the screen. So here are the basics of the assembly programming language. We talked first about the registers, and then some instructions and some interrupts which we are going to use later on. We're going to build a basic calculator, just a simple one, which will use in it many functionalities will help you in learning and mastering the assembly language.